Okay, hello and welcome to the GCS Sharpe Engineering webinar. I'd like to thank everyone for their time today. My name is Rob Kinnear. I'm Director of Strategic Partnerships here at GCS, and I'm here to introduce Dr. Alex Philp from GCS and Jim Sharpe from Sharpe Engineering. We're going to keep this webinar to 30 minutes only. I think 10 to 15 minutes of discussion, and then 15 minutes of question and answer will be the format. And basically, we want to spend this time to have Alex and Jim take mainly IBM folks who are invited to this webinar to take you through the key points of why the team matters and how the Sharpe and GCS team can assist you help your clients. Both companies have multiple domain expertise in streams, deep knowledge of streams analytics through streams reference architecture, streams coding, and streams consulting, how to truly optimize streams applications. Both companies have done this in multiple domains. And we really wanted to let you guys know why the GCS Sharpe team matters and how we can help you work closely with your clients to be successful with the streams technology. Both companies are very early adapters and pioneers in streams technologies, and we want to let IBM folks know that we're here to help. And without further ado, I want to turn it over to Alex so he can further send this message to you guys and help define why GCS and Sharpe matters.
Hey, Rob, thank you very much, and welcome to all of our visitors from IBM and our partners at IBM, and welcome, obviously, to our teaming partner, Sharpe Engineering. As Rob just mentioned, we at Sharpe and GCS agreed earlier this year that given our backgrounds and experience and knowledge working with IBM and working with clients and customers with streams, that it would be smart to join forces and combine our knowledge and expertise across a variety of verticals and industries. And that's what we're going to be talking about today. A little bit about GCS. We are the company behind the original commercial license of streams from an OEM perspective. We were the first licensee in the world and worked with a lot of our sister companies to bring that capability to market for the U.S. government and the Department of Energy. We at GCS focus a lot on geoanalytics, essentially location, spatial information, and we've developed expertise in cloud, mobility, and analytics. We think streams and the streaming platform is a game changer, continues to be a game changer, and that's why we're here, is we want to let more IBMers know about the GCS Sharpe team and what we can do in that space. Rob, next slide. I'll turn it over to Jim now, and he can share a little bit about Sharpe.
Hey guys, so I've been working with complex analytics for about the last 20 years, and by complex analytics I mean solutions that require not just one technology, but some sort of combination of Bayes nets and neural nets or decision trees or custom code or various different kinds of predictive models. And I've been looking around for many, many years for the right infrastructure, the plumbing, to connect all of these different bits and pieces into a semantically consistent solution. And when I discovered streams a number of years ago, before it was actually an official product, hair stood up on the back of my neck. And I've been passionate about data in motion ever since, and very focused on streams-based solutions, specifically as it relates to harder, tougher challenges that are probably difficult to accomplish in any other way.
So, thanks, Jim. So essentially what we wanted to talk about here briefly are the key selling points or the talking points about the team, GCS and Sharpe. Earlier this year, we went back and had a meeting with IBM Research, and obviously are very plugged into the IBM product team, the research team, as well as the sales team led up by Roger Ray. But we tried to boil down key points that might be valuable to the attendees on the call today from IBM, and that, of course, is a tremendous amount of award-winning expertise in utilizing and working with streams, literally from reference architectures all up. Rob, maybe you could go back. Maybe from expertise in coding, hardware, software, networking, the whole 9 yards. Our two companies together have worked on multi-million-dollar implementations and with real clients, with real customers that are very, very much enterprise-class systems that were cutting edge in the time, definitely pushed the envelope in many areas, and resulted in significant recognition on the part of IBM in terms of a movement forward. I think a key thing in today's world, more so than ever, is the affordability of GCS Sharpe in terms of our cost effectiveness. Very affordable, can bring a lot of value to the IBM account managers and others that are looking to be successful with their clients. Given the money that is available today, when people are deciding what they're going to spend money on big data on, it matters what it's going to cost to implement this stuff. And then finally, and Jim made this point as we were preparing for this webinar, and I think it's key, when you deal with GCS and Sharpe as a team, you've got agility. We're 24/7 operations. We're very, very agile. We make a living being agile, and that allows IBM account team members, client members, to move on a dime if necessary. We can be up and running on contract, defining scope, defining methodology very, very quickly, and you combine affordability, agility, along with experience and expertise, and those are just key talking points that we have that your clients and your customers and the customers you're chasing are going to want to know. Final point on this slide, both Jim and I, and as members of our teams and our extended teams and our sister companies, spent thousands of hours, hundreds of hours on phone calls over the last 3 to 4 years doing reference work, basically providing your clients with the knowledge and expertise and confidence that these things can be done, and they have been done, and basically start to reduce risk, fear, and uncertainty on their acquisition of streams, and obviously the team to put it together. We've worked on those experiences. Next slide, and I'll turn it over to Jim.
Just piling on a little bit with what Alex was just saying, and to raise sort of one additional point, our track record of successes with this particular platform don't necessarily take away from other IBM products and services offerings. On the contrary, every success that we create builds the ecosystem. It adds validity. These referenceable, happy clients are really better for everyone. And as the ecosystem of successful implementations grows, that should make sales easier all the way around. On this particular slide here, what we're trying to convey is we haven't just done the easy things. We've pushed the envelope. We are early adopters. We are sophisticated implementers, and the capabilities we bring to the table are something that is above and beyond what you might see from other third-party systems implementers or integrators that may have a handful of engineers that have gone through Streams training. We're the heavy hitters as far as Streams implementers go.
And just to kind of illustrate this, since so many of you on the call are worrying about accounts and worrying about growing accounts, and really what it comes down to here is client solutions. Between GCS and Sharpe, some pretty remarkable industry solution expertise and knowledge base. So clearly, we cut a lot of teeth in the U.S. government in DoD implementations, above and beyond kind of the core that IBM has been servicing and servicing very well. A lot of work with the Navy, other applications in the intelligence community. Some interesting work that may be of interest to folks in state government. Obviously, the Department of Energy, very, very big reference case study on the DOE story in dealing with acoustic information. I think I'll let Jim describe his work in the energy sector and the healthcare sector a little bit. Jim?
Yeah, so a couple more of my recent and current engagements, starting off with Excel Medical. They have a user group that is very focused on the InfoSphere Streams platform to do real-time medical telemetry in the emergency room. And they've put together a large and comprehensive consortium of thought leaders in the industry, many universities and private institutions, for doing cutting-edge analytics on real-time medical telemetry, things like EKGs and heart rates. And what we're doing with that is we're taking that data and monitoring these patients millisecond by millisecond, looking for subtle indicators, trending. Basically, what this will allow us to do is as we develop these algorithms, it will allow us to, or the doctors to identify conditions much sooner in the process while there's more treatment options available, and we can reduce the risk. For CenterPoint Energy, this is a multi-billion-dollar electric utility. This particular effort was on their regulated side, so this is power distribution. They have over 2.3 million smart meters and a whole bunch of infrastructure that they need to monitor. So basically what we're doing there is we're using streams as for sensor processing for operational analytics.
Extending into the civilian world, GCS just started a project with NASA that basically helps NASA connect sensors to systems using streams as a processing engine for basic information into command and control systems and human interfaces. So NASA is really exploring how streams could be used, and some of the open source competitive realities of streams could be used for the Internet of Things. We've been writing and discussing about that. A real exciting project getting off the ground with the Forest Service, again, in using streams to help basically do heavy lifting and computational lifting of the right model at the right time, kind of building on the notion of analytics as a service combined with modeling as a service for fire rate of spread, basically looking at fire risk and how it's impacting property, how it's impacting lives and resources. Being in Missoula, Montana, it's a mecca for this kind of stuff, and we're excited about those. And then a whole bunch of work working with FSIs, Federal Systems Integrators. So can't get specific names, but you know who they are, but they may or may not know about streams. They want to use streams. The one that is available for public information is the Lockheed Martin spin-out. The SI organization was the first, one of the early users of streams from our perspective in terms of doing some pretty remarkable work in terms of geospatial analytics and system dynamics. And in getting back to Jim's client base and working in the health sector, we see significant growth not only of data at rest analytics in healthcare, of course, through big insights and other elements of the big data platform that we collaborate with, but also people are getting increasingly interested in the real-time dynamics, both in terms of out-of-hospital and in-hospital systems. So you kind of create a micro and a macro strategy for health. So in our work with IBM, we've been looking at aligning the GCS Sharpe team to the major verticals, government at various levels, obviously the energy sector, both government and private, health, and then retail. And the one area I just share is that we've got a couple examples that we've shared over the past at GCS on a previous webinar last fall that actually has streams working inside to help retailers and marketing strategists look at consumer sentiment in the LA basin, basically processing anywhere from 900 to 1.5 million tweets a day and extracting from that some very important information to help marketers understand not only to whom to send a message, but where to send the message on mobile devices. And we could, in another webinar, Jim and I could go through that and we could unpack that. So kind of a nice range of competency and capability, both domestically and internationally, to help IBM account managers be successful with streams implementation, stream success, et cetera. And I think with that, I'm going to turn it back to Rob. We're about 13, 14 minutes into the webinar. We wanted to keep this stuff up front very quick. I'm going to turn it back to Rob to facilitate the Q&A.
Yeah, thanks, Alex. So if any of the attendees have a question, feel free to type in your question in the question box in the GoToWebinar icon on your upper right-hand corner, and I will be able to read those questions to Alex and Jim and have them answer. Okay, looks like we have one coming in. This is not specifically to either one of you, but probably both of you, and it says, in relation to algorithm development, what are the challenges that the companies have faced in terms of taking a static algorithm and turning it into a streaming algorithm utilizing streams?
Okay. Well, this is Alex. I'll go first, and I know Jim has unbelievable experience here, and we both dealt with this big time. Great question, by the way. You know, we've got data in, data out, and in the middle we've got analytics in real time. And I think Roger Ray, 4 or 5 years ago, we started talking about this notion of real-time analytical processing, the key words being analytical processing. So the projects we've worked on have actually bizarre, incredibly aggressive, computationally intensive processes that are going on. One example, we often run into clients that have done modeling or developed an algorithm, the mathematical formulation, maybe in MATLAB. And it's not easy to necessarily take those heuristics and those formulas and just pop them into streams. You've got the packaging, you've got the work done there, but you also need to look at scalability of the algorithm and how it will perform volumetrically against clusters, against cores, and really the vertical and horizontal scale out. One area that we developed some pretty interesting capacity on, both in the power chip base as well as the Intel base when you're dealing with an x86 IBM hardware, the power hardware, is, you know, working very closely to make sure that we can call those math libraries to simulate and model the ability to perform the math. Jim and I were just working on a problem actually last week on a whiteboard where we're doing an unbelievable amount of FFTs a second basically to have the data necessary to perform the work on a particular unstructured data type. In this case, it was audio, but we've also worked on some very aggressive things dealing with video and, you know, some of your more difficult unstructured data types, you know, beyond just text. I mean, that's my first answer. Jim, I know you have a lot of expertise in this space.
Yeah, we could probably cover an entire webinar over just that one topic, but a couple of high-level thoughts just to sort of throw out some answers here is one of the selection criteria for identifying good candidates for streams is, can the algorithms that are being discussed be transformed into something that is appropriate to be applied incrementally to, say, a sliding window on the data. That's not always the case. However, in most cases it is. Because streams emphasizes the recent, you basically just transform that question into what are you looking for now, as opposed to what are you looking for in general. And this is one of the most successful patterns that we've used for a number of my clients has been to combine data at rest and data in motion. So it's fairly typical for us to use various different forms of data at rest analytics, whether it's something like what Big Insights brings to the table or various different forms of machine learning. But what we'll do is we'll look at the historical record to identify important things to look for in the live real-time stream. Then what we do is we code that scoring engine up into something that can execute in the streams platform, and it actually does the looking for. So data at rest decides what to look for, and then streams actually does the looking on the real-time stream, on the real-time data.
One other thing I'll add real quick, and then we'll get on the next question, but we oftentimes it's not only the scalability and the performance objectives of quote-unquote the analytics as referenced by algorithms, but a lot of expertise and knowledge and just brute force, blood, sweat, tears on hybrid hardware architectures. So the idea that maybe you want to optimize certain part of your processing on the CPU, certain on GPU, certain on the FPGA, and distribute different parts of your flow, your analytics, depending on the data, the media, what you're doing in different areas. So we'll often take Jim's point and combine that into an FPGA logic controller to keep up with extreme rates let's say we're doing network analysis, network packet analysis, and then get everything cleaned up and getting ready for this process and this process and this process. Also, a lot of knowledge and expertise, talking to different sensors and figuring out how one sensor can cue another sensor. So technically an algorithm, but really a workflow. Great question, by the way. That deserves a whole other webinar. Rob, duly noted. Let's do another one on analytics and streams. Next question, please.
Okay, next question comes in. It states, how have either companies gained traction with U.S. government customers, and how have you been able to deliver on expectations regarding low latency, and can you provide any metrics?
Okay, well, that's again another great question. People obviously know what they're asking about today. That's great. How we gain, that's a lot, there are a lot of questions in there. So how do you gain, Rob, the first one was, how have you been able to gain traction with U.S. government customers?
Correct.
Well, the first thing is we were the first at the table beyond the typical IBM U.S. government relationship, and in many ways we saw this bright, beautiful little baby, and we wanted to go help the baby grow up. So we were very early, both GCS and Sharpe were very early in that which was commercially available and released, and to go then and go look at other government problems. I think the way that we earned the trust and the confidence of our government clients was through a classic proof of principle, proof of concept, and then ultimately a multi-phase program over at least a couple of years. And it was a multi-million-dollar engagement, but we started with baby steps and worked our way up. We had to prove to our client that we could deliver things that they could not get traditionally, given a very dynamic, complex data set. In other words, it wasn't just a lot of data, and it wasn't a lot of variety, and it wasn't a lot of volume, and it wasn't an issue of veracity. It was all of it combined at the same time against some complex things, and they wanted a lot of flexibility from that perspective. Really, really hard requirements. So we kind of took them through a process. Second of all, the other part of the question, Rob, was benchmarks.
Yes. How did you deliver on expectations regarding low latency, and could you provide metrics?
Okay, well, we did provide, we just absolutely were completely transparent with our client. Latency was, there was no latency allowed. It was classic line speed, real time. And the metrics, some of them I can provide, but at the end of the day, we had 5 gigabit Ethernet lines connected to a really, really high-end IBM 3850 machine. We were running, I believe, 24 cores. We hyper-threaded those to roughly 48 cores. We had a lot of data coming at us. A lot of it was garbage. We had signal processing algorithms. We had FFT algorithms. We had classification algorithms. We had noise floor algorithms. We had high and low band pass filtering algorithms. But we had to keep up with that, and I think at the end of the day it ended up being probably 5 or 6 gigabit a second in, running across. We had FPGA controllers doing a whole bunch of things, and then we let x86 do its job. If you added up that processing against the particular sensor system we were working with, and you hooked up 5 or 6 of these systems, you had actually close to 9,000 sensors, all detecting things, all in real time. And if you turn that on for 24 hours a day, 7 days a week, our basic calculations were somewhere between 24 and 27 petabytes, of which we were blasting through and analyzing and then pulling out only a small amount of that. Going back to Jim's point, and the Netezza guys, we were doing continuous dynamic and non-dynamic calibration of our models, of our algorithms that were being used for detection and classification of signal. And that was almost 4 years ago. So we've learned a lot since, and we've continued to evolve. That's one story I have about the government, metrics, earning trust, and that's why that work got some recognition. Now, we would have loved it to have gotten a lot more recognition, but again, given the client and the problem and the mission, we worked very closely with IBM to be able to tell that story, but a lot of that, we can't say a lot about who, what, where, when, and why other than what I've shared. Jim, I don't know, did you have anything else you wanted to share on government stuff?
Yeah, a lot of that is going, or what I want to say is essentially a repeat of what you're saying, but I think it bears phrasing in a slightly different way. It's getting a lot better now, but data in motion really is a different animal than these people are typically used to doing. So some sort of flavor of starting small is absolutely the right way to go. This is where the agility of the Sharpe GCS team or comes into play is in a very short order we can prove to them that this particular platform can do what it's claimed to do, but more importantly in their environment with their data and their domain expertise. So there's lots of nice glossies out there that says how good some of these platforms are, but they need to test the waters first. And some of these, whether you call them proof of technology, proof of concept, proof of whatever, or some sort of pilot, some of those are too small to be of interest to some of the larger system integrators. But getting your toe in the door, showing success with something that is manageable, that's the kind of thing that leads to trust. We haven't done a single project where we didn't have identifiable, measurable metrics keyed or queued up before we even started the first line of code. So we knew how we were going to measure the success of each of these pilots going into it. And then it's just a matter of did we meet all those goals? And we've never failed to do that. Every case where we have gotten a chance to implement one of these small initial projects, they've all turned into something bigger.
Okay, great. Thanks, Jim. We only have a few more minutes, but we have a couple more questions, so we'll try to get them answered in the time allowed. The next question is regarding data formats. Typically, we see streams working with semi-structured and unstructured data. Do you guys have any experience dealing with raw or binary or quote-unquote dirty data, and what challenges have you faced regarding those types of data formats?
Yeah, we did. We have audio, classic raw binary stream. Streams operated quite nicely on it. We did do conversions from that data form to another data form in stream, so we could run other analytics on it because it was a little easier to probe it. We were doing some basic work on magnitude, density of raw binary that was coming from an electrical optical system. Recently, we've been looking at some areas in electromagnetic. Jim and I are working on a problem right now for a large academic institution in the healthcare sector that basically has data coming out of some really, really interesting medical devices that also have some basically frequency bins and some things. It's doable, totally doable, actually, and I guess our predilection has been that it works quite nicely on completely unstructured data, and including these these basic data streams that have yet to be converted into anything else. Jim, I know you've done a lot of work in this space too.
Yeah, I'll try to be really brief because we're short on time here, but that electric utility that we referenced back on one of the client slides has many, many proprietary systems. Half of their systems do not have standard protocols or data formats, so much of the work that's required to integrate with those systems involves some sort of proprietary binary format. One of the things that we really like about streams is its extreme flexibility in terms of adapting to other systems, whether it's data in motion, data at rest, different proprietary formats. We can basically code up a custom interface to any, if it's data and it's electronically available, we can hook up to it. The other thing that I'd like to add is the computational efficiency and the richness of the streams environment allows us to do an awful lot of data cleanup that would be very difficult to do with, say, a complex event processing system or something that was focused on streaming processing, but maybe more related to tweet sentiment analysis as opposed to numeric processing.
Okay, great. Thanks, Jim and Alex. We're a little short on time. We have one last quick question regarding hardware, and it is, Have either of companies deployed a solution on a Power Linux machine?
Yes, and I think we have, and we had some pretty good results early on. Streams was not optimized for power, but it became optimized for power. We were very happy with the performance, and we have delivered solutions on power.
Just to chime in there, all of my clients happen to be either AIX or Linux shops, and they through independent evaluations had chosen the x86 platform. So it's not that I have any issue against power. It's just my clients happen to be x86 Intel shops.
Okay, great. Thanks, Jim.
One thing I want to say one thing there, Rob, which is kind of a teaser. I know you got 30 seconds. See where Watson's going on power. Look at Power Linux for streams, and look at the implications, folks. It's going to get exciting. Back to you, Rob.
Okay. Well, we'd like to respect everyone's time and keep it within 30 minutes, and that's about where we are. For your colleagues that happen to not be able to join the webinar, we have recorded it, and we will post it to a YouTube link that I will distribute to all the IBM folks that we invited for the webinar. And on behalf of Alex and Jim and myself, I would like to appreciate everybody's time, and thank you for joining.
Thanks a lot, Rob. Thanks, Jim. Thanks, everybody.
Bye.